Welcome. As we have learned earlier how to move the gases in the natural gas processing, here also we are now going to look into how the liquids are going to be moved in the system. And as we know that in any kind of plant, both gases and liquids are there at various points and various locations, and they have to be moved over long distances in the plant. So it is very much important for us to know to have some basic idea about how to move the liquid and how to do some analysis to know the performance and some kind of design of the fluid moving machineries. So in this particular lecture we shall be looking into the various types of pumps which are used in the natural gas systems, and in this we shall be learning about the classification of the pumps, the positive displacement pumps, the kinetic pumps, the selection of the pumps, and the performance of the pumps. So first let us see that what are pumps. The pumps are some liquid moving machinery what they do that they move the liquid from one place to the other by imparting some kind of energy to the liquid. Now here we find that the energy which is imparted to the liquid, it may come out as in the form of the pressure increase, that is pressure energy, velocity increase, that is the increase in the kinetic energy, or both, that means both pressure energy as well as kinetic energy may get increased. And then generally, because we are talking of the liquid, so the flow is generally taken as incompressible, unlike in case of compressors where we are using gases, there the flow is taken as sometimes as compressible. Now the performance of these pumps depend on the type of fluid we are handling, the shape and size of the pump, and the rotational speed if there is any kind of rotation. So here in this schematic diagram we can see that we are getting some low energy fluid which is going through the pump, and we are putting some mechanical work into the pump, and that is how we are able to increase the energy of the outgoing fluid. Now there are various classifications of the pump. Broadly they are classified into two groups. One is the dynamic and there is the displacement. And again these dynamic and displacement are further classified. Now we see the dynamic can be classified into centrifugal pump, then the special effect pumps. So we can see radial, mixed flow, axial flow, and the special effect pump like airlift pump, jet pump, vortex pump, rotating casing, drag pump, shear force pump, and many things are also getting innovated and invented in the with more and more depending on the kind of applications we have. And similarly we have many classifications for the displacement type of pumps. In this we have reciprocating, rotary. Under reciprocating again we have piston type, plunger type, diaphragm type. Under rotary we have single rotor, multiple rotor, and here also we have screw pump, piston pump, and sliding pump. And in this we have multiple rotor, we have gear pump, lobe pump, screw pump. Now definitely this particular course is not about pumps, and separate courses and books have been written on the pumps. What we shall be learning in this, that what are the very commonly used pumps in the natural gas industries, and some even that is not exhaustive, but some common ones, and how to assess them, choose them, select them, with those things we shall be looking into this particular lecture. So first we come to the positive displacement type of pumps, and in this what we see, the positive displacement means we are displacing the particular liquid positively by giving some mechanical force. So here we have some, it adds energy to the liquid by direct application of the mechanical force. And what happens then, that to do this kind of pump traps a certain amount of liquid and mechanically moves and forces it out into the discharge line of the pump. And you can say this operation is something like the way we are using the syringes for injection. So we are first sucking in the liquid and then pushing the piston in the syringe to push out the liquid. So this is a similar manner you can imagine that this kind of pumps are working. Only thing is this, they differ the way this mechanical energy is imparted to the liquid. That's how we are getting different types of the positive displacement pumps, and they are suitable to handle highly viscous liquids, and they are self priming, and have ability to handle liquids with a certain volume of entrained air. And priming, you know that priming is done so that we can drive out the entrained air. Otherwise, what happens? The liquid cannot get sucked in, because the liquid pressure has to be more than the pressure inside the pump. And if and we know that for example, for water we need about 10 meter of water height to get 1 atmosphere pressure. So if there is some kind of air trapped inside the pump and it is at atmospheric pressure, then we need that large hydrostatic head of the water column to make the water go into the pump. So there we need some kind of priming, so that the trapped air should not stay inside the pump. So in this particular type of pump, reciprocating pump, there is no problem with this, because whatever trapped air is there, whenever we are using any kind of mechanical force, that by the force we are able to drive out the trapped gas, trapped air, and that is how it is a self-priming kind. And this kind of pumps give very high head and low discharge. And then we have the dynamic or kinetic pumps. As the name suggests, that kinetic means we are imparting some kind of kinetic energy, or that is coming in terms of the velocity. So in this, kinetic energy is imparted to the liquid within the machine, and by doing so, what we are doing, we are increasing the liquid velocity, that is more than the discharge velocity. Now why we are doing this more? Now why? Because again we are reducing that velocity imparted to the liquid, and when we are decreasing the velocity of the liquid, we are able to recover the pressure which was lost during this increase in the velocity. That is, we are basically going by a energy balance, and we can say that we are using some kind of Bernoulli's equation, that's energy balance. That energy balance we are using to first increase the velocity of the fluid more than the discharge velocity, again reducing the velocity to recover the pressure, so that we can generate some pressure in the outgoing liquid. This kind of pump generally gives low head but high discharge. So now what we shall be doing, we shall be selectively, not all of them, but selectively we shall be looking into the working of some of these pumps. So first let us look at the piston pump, and as the name suggests, that it has a piston which will be moving to and fro to drive the liquid out and suck in the liquid. It is same as the kind of syringe we find for our injection. So here we have a piston to force the liquid from the inlet side of the outlet to the outlet side of the pump. And here we find how it is working, that this is, here we find this is suction side and this is the discharge side, and we have a discharge valve here and a suction valve here, and here we have with a rod, the crankshaft. The rod is connecting the crankshaft with the piston, and the piston is undergoing this to and fro motion. So what happens in suction cycle? The pistons move rightward and the pressure reduces in the pump body and causing this suction valve to open. So when it is going to other side, you can see when it's going the right hand side, this valve is opening, and once this valve is opening, the liquid is getting sucked in, and when this is sucking in, this valve is remaining closed. So no liquid can go out during this suction cycle. So this is a suction cycle, and high pressure in the discharge line keeps the discharge valve closed. Okay, so that is how it is only sucking. And then with a discharge cycle, that means that when it is going on the left hand side, the liquid, this valve is again opening and this valve is closing, so that this liquid is able to move out from the discharge or the delivery line. So this is how this kind of piston pump works. Only in this case we find that there will be a time gap between the suction cycle and discharge cycle, due to which the flow which is obtained from this kind of an arrangement will be intermittent. Sometimes it will be there and sometimes it will not be there, but generally we want a constant flow rate, and so for that what we do, we go for a double acting pump, and it is to reduce the intermittency in the discharge flow. And we have now two pairs of suction and delivery valves. Now you can see this is one suction line, this is another suction line. This is one delivery valve and this is another delivery valve. And we can see that these are placed one is in the front of this is a piston. So one set is in the front section and another set of this suction and delivery valves on the is behind the backward of the piston. So what happens, one of the pairs will be acting at a time. So we find that when this piston is going to the right hand side, this discharge valve is open, and at that moment, so the liquid is flowing out of this discharge valve in a manifold. At the same time, this suction valve is open behind the piston, so that the liquid is coming through this section. And once what happens, once it delivers, now this piston will move back. When it moves back, what happens, this suction valve closes, this discharge valve opens, while this closes and this opens. Now what happens, the liquid will now start coming in through this section and will be delivered out from this section. Okay, so that is how we are finding that from the same manifold, either this or this valve is active in sucking in the liquid, and in the same manifold, either this valve or this valve is active in delivering the particular liquid. And that is how what we are finding in this manifold, we are always having the liquid present at all time, so that we are able to reduce, if not eliminate, because the amount which is going out through these valves may be differing, because the space available behind the piston and in front of the piston are slightly different. But overall, we shall be finding we are able to reduce the intermittency of the liquid flow rate quite well by using this double acting pump. So this is what was staging of the pumps. So that is how this double acting works. And then we go to the gear pump, and as the name suggests that we have two gears, and here what we find, the liquid is coming through this side, okay, and because these gears are moving and this liquid is taken from these two sides, there is a casing in which the gears are placed, and we find that the liquid is going either from this side or this side, and then there it is getting compressed when this it is going through this, and this compression is increasing the pressure in the liquid, and then it is passing out from the delivery line. So this is the way this gear pump is able to pump out the liquid, and the output of the gear pump is independent of the discharge pressure, and it can work at a low speed. And if can be worked at a low speed, it means that we can have quite smoother operation and we can make it more controllable. It can handle very viscous fluids, but it is not recommended for abrasive media or solids, because in that case what will happen, the wall of this casing will get damaged. So that is why it is not recommended for abrasive media. And also the gear teeth, the teeth of the gear, they can also get damaged by any kind of abrasive material. And but because of this rotational thing and this gear meshing up here, there could be a lot of noises in the environment, and it can handle low flow rates. And then we come to another type of pump, that is a vane pump. In this case, you can see that what are the vanes? Here we have the vanes, and first thing is that this is a rotor part, the pump rotor we can see, and in the pump rotor we have many groups in the rotor. So these groups are generally equispaced along the circumference of the rotor, and in each of the groups we have some what we call sliding vane or blades. Now sliding means these vanes can go inside and outside of this each of the groups. And how do they go inside outside? This will be guided by the casing, and this rotor is placed eccentrically with the stator, that is the outer casing. Why? Because if we do that, what will happen? All the vanes will not be inside together, neither they will be outside together, so that we can get some of the vanes will be inside and some will be outside. And why? Because when the vanes are inside, suppose this eccentric, what happens? These vanes which are away from the casing will be opening up, they will be coming out of these things, so they will make way for the liquid to move inside the pump. But though the vanes which are on this side, they will get pushed in and they will be moving in, so the no liquid can pass through this side, the liquid will pass only through this side. So what will happen? While these veins are active, they are going out and they are letting the liquid pass in. The other veins are not able to make the liquid pass, because there is no hardly any clearance between the veins and the casing. So liquid is moving up and is going out from the discharge side. So this is how these vein pumps are working, and the pumping rate is controlled by the rotational speed and the eccentricity. Okay, it means how the axis of the rotor is displaced from the axis of the casing. These axes are not matching, they are away from each other. So that is how we are getting the eccentricity. Now this is, here we find that how these rotor pumps are working. We can see that how the veins are working. If you look at this figure, the veins are coming out, and as soon as they go inside, they are moving inside. Similarly, we find in this thing also that veins are out, and as soon as they go to the other side, they are coming inside, and the liquid is flowing only through this side. So there is no liquid is flowing from this side. So that is how we are able to get the pumping action in this kind of vein pumps. Next we go to the screw pumps. The name suggests that we are using some kind of screw, and you can see these are the screws here, and here from here the inlet is coming here, and the screws are there, a pair of screws through which the liquid is flowing, and then we are finding that this because of this reduced spacing between the screws, this liquid is getting pressurized, and ultimately it is coming out from this delivery line. So it is using two or more screws that intermesh to pressurize the liquid, and they move out of the system and offer the highest flow rate of among all the positive displacement pumps. So because of the intermeshing of the screws, we are able to generate the high pressure, and it can handle two-phase vapor liquid mixtures. Next we come to the kinetic pumps, and under this we come to the centrifugal pumps. We shall be looking in general. Again, we find that under the centrifugal pumps we have various other pumps like radial pumps, axial pump, mixed pump. So we shall be looking into the centrifugal, the normal centrifugal pump, that is basically the radial centrifugal pump, and here we have the working of the radial pumps. That here first we see that what we have a suction eye, and this is the impeller. Through the suction eye the liquid enters, and as it goes on the impeller, and this impeller is rotating, and due to the rotating motion of this impeller the liquid is sucked in, and once this liquid comes on the impeller, it acquires the centrifugal acceleration, and as it moves away from the center, what happens? We know that omega square r, the r is increasing, so the this acceleration is increasing, and when it goes at the tip of the impeller, the liquid is attaining the highest flow rate, and once it comes to the thing, it leaves this impeller, what happens? It comes to what we call the volute casing. So it comes to volute casing, and this volute casing, as you can see, it has an increasing area of cross section, and once the area of cross section increases, what happens? The flow rate reduces, and when the flow rate reduces, what happens? The pressure starts increasing. This is the energy balance. So Bernoulli's equation you can use. So what will happen? That the velocity reduces, pressure increases, and at the discharge line we will be able to recover much of the pressure, and it will be quite high. It is higher than the inlet pressure. So that is how we are able to get the pumping action for the centrifugal pumps, and once this pressure is there, so the liquid can be moved up at any other location up. So here we see how the things are working, that from the eye the liquid is coming in, and then it is going on the impeller, and this, as it goes to the impeller, it goes to impeller tip, then it goes in the volute casing, and the volute casing, as you can see, the area of cross section is increasing. You can see it's kind of diffuser section, and then the pressure is increasing due to decrease in the kinetic energy, and ultimately we are getting a high pressure liquid. Now before we end, we are going to the way that we select the pumps. So here generally we have the head versus the capacity. What happens? We have to look at two aspects when we select the pumps. That head means that how much pressure drop it can encounter, and we may have to pump the liquid from a bottom plane to the top plane. So, how much head we can generate from a given pump and at what capacity. So, we want sometimes both high capacity and high head, and sometimes we want low capacity high head, or sometimes we may have some other combinations. So, here we find that various types of pumps have been given, and this kind of graph we can use to have a first guideline to choose the kind of pump we need for a particular application. So, if we know the head required and the capacity required, we can find out which kind of pumps would be used, and you can see the various types of pumps are given here: axial flow, mixed flow, rotary flow, then centrifugal, reciprocating, then high speed centrifugal, then there are other pumps peripherals. So, there are various. So, this is one of the representative guidelines. Similarly, the manufacturers will give us the different types of this kind of charts from which we shall be able to select the appropriate pump for a given application. And these are some of the books which you can refer to for more detailing and explanation about the pumps. Thank you.